to class with Professor B. We are going to take a look at complex fractions today. Okay, so complex fractions look scary. They're really not. All you're doing is dividing. Okay, if you don't remember how to divide fractions, I'm going to kind of run through it fast here, but I have another video on multiplying and dividing fractions. You should go check that one out. Okay, so we are simplifying complex fractions. All we're going to do is divide. We're going to divide fractions, okay? So if I take a look at this first example, this is our mild example, okay? We are going to look at 2 divided by 3 divided by 2x divided by 3. It's a lot of mess, okay? So what we're going to do is we're going to break this down into 2 fractions. So all I'm going to do is I'm going to break the first fraction, 2/3. This division bar right here, this fraction bar, I'm going to use that as a division symbol, and then 2x divided by 3. So we have 2 fractions, okay? All I'm going to do now is I'm going to rewrite this as 2 divided by 3, or 2 over 3, divided by 2x over 3. So top part of my complex fraction is right here. Bottom part of my complex fraction is right here, okay? So when you're dividing fractions, we don't really divide. What we do is multiply by reciprocal, all right? So go ahead. It is multiply by reciprocal, okay? What does reciprocal mean? Reciprocal means flip the fraction. Flip fraction. Think about angry flipping a table. You're just going to flip it over, all right? So we multiply by the reciprocal. Again, this is why math can be easier if you say things out loud. This is 2/3 divided by 2x over 3, or 2x, yeah, 2x thirds, okay? So because I said divided by, this is the fraction that's going to be flipped. Okay, that's why we have, when you say parts out loud, that can help you with what you're gonna flip and what you're not gonna flip. Okay, so I'm gonna keep the 2/3. The division is going to turn into multiplication. So multiply by reciprocal. So instead of the 2x over 3, that is going to flip to become 3 over 2x. So I am multiplying by the flip fraction, okay? From there, we're going to multiply these fractions. How do you do that? You multiply straight across. So I'm going to multiply those guys. So 2 times 3 is 6 over, and then multiply the denominators. 3 times 2x is 6x, okay? Don't forget to simplify. Don't forget to simplify if you can, okay? If I look right here, I have 6 divided by 6. That's 1. All right, so that simplifies. And I end up with a 1, because 6 divided by 6 is 1, over 6 divided by 6 is 1. So both of these would become 1s, except we don't usually write the 1 next to the x. So I'm just going to write 1 over x. And that is our simplified fraction. Okay, so when we look at the original problem here, we're going to have this big thing, 2/3 divided by 2x over 3. We broke it down into 2 fractions, and then we multiplied by the reciprocal to simplify. Okay, so let's take a look at one that's a little bit spicier. All right, let's take a look at our medium example. All right, now we've got a little bit of work that we have to do in our numerator before we can divide by our denominator, all right? One way sometimes this gets a little tricky is people think, oh no, I don't have another fraction in the denominator. You can make it that way. All we have to do is we put this 4 over a 1, and now it's a fraction. So we're still going to take the same steps we did for the mild one. We're going to have our numerator. This is still our division symbol divided by our denominator, okay? So we're going to take the same steps. The only thing we're going to do is we're going to clean all of this up first, okay? We don't like to leave two fractions in the numerator, all right? So we're going to clean that up. So again, refresher on adding and subtracting fractions. You have to have the same, move this down here, you have to have the same denominator. So I have a over 8 minus 4 over a squared. Okay, we can't combine these because of the 8 and the a squared, so we're going to make them the same. How do we do that? We're just going to multiply these guys, the two denominators, to find a common denominator. And that always works. You might have to simplify more later, but if you just want a surefire way of finding a common denominator, just multiply your denominators together. Even if you have multiple fractions, just multiply your denominators together. All right, so we are going to do that, and we are going to end up multiplying this first fraction. We're going to multiply it by a squared over a squared. We're multiplying the denominator by a squared so that we can get that common denominator, but in order to keep the value of the fraction the same, we have to multiply the top and bottom by the same. That's why it's a squared over a squared. Okay? And then on the other side, again, we're going to multiply the denominator by 8, so we have that common denominator. But whatever we do to the bottom, we have to do the top so that we keep the value of the fraction the same. Okay? Again, we're multiplying fractions. We did that earlier. So if I multiply a squared times a, I am going to get a cubed. If I multiply a squared times 8, I am going to get 8a squared minus, multiply 4 times 8, that gives me 32. Multiply a squared times 8, I still get 8a squared. Keep simplifying. Now I'm going to make it all one fraction. Since our denominator is the same, I can add or subtract depending on what the sign is. This sign is subtraction. So then I'm going to get a cubed minus 32. I cannot simplify a cubed minus 32, so this has become my new numerator. Again, we had that just a second ago down here. This is now written as this, so it's just that one fraction. We like that. Okay, so now we're going to go on to the other steps we have done before. We will have a cubed minus 32 over 8a squared divided by 4 over 1, so that we have a fraction. Okay, so that is numerator of our complex fraction divided by denominator of our complex fraction. How do you divide fractions? You keep the first, so a cubed minus 32 over 8a squared. Division becomes multiplication because we are going to multiply by the reciprocal, and then we are going to flip this fraction here. So this is going to become 1 over 4. And then we're going to multiply across like we've done before. We're going to have 1 times a cubed minus 32. All right. Remember, when you multiply 1 by anything, it is itself. So I'm just going to have a cubed minus 32 over, and then I'm going to multiply 8a squared times 4. 8 times 4 is 32a squared. Okay. There is nothing in common between these three terms. Okay. So I cannot simplify. I know there's an a here and an a here, but you can't cancel those out because there's nothing here. I know there's a 32 here and a 32 here, but because there's not a 32 here, we cannot cancel that out either. Okay, it's got to be in common with everything. So in this case, we are done with our mild example. All right, so if you end up with a addition or subtraction problem in the numerator or denominator, you need to clean that up first before you move on to the multiply by reciprocal. Okay? All right, guys, I got one more example for you. This is going to be your spicy example. Look at that. It looks, again, it looks way scarier than it really is. I promise you that. All right. So again, I'm going to break this apart. I have my numerator. This is divided by my denominator. All right. I have another issue where I am going to want to clean up a part before I move on to the division of fractions. Okay. So let's do that part first. We will have 1 over x minus 4 all over x plus 1. Okay. We're going to treat this the same way we did our medium example. We are going to combine our two denominators so that we get a common denominator. So that means that this fraction is going to be multiplied by x plus 1. That gives me the common denominator. To keep the value the same, I also multiply the top by x plus 1. For my second fraction, I have x plus 1. I'm going to multiply it by x in my denominator to get my common denominator, but then I have to multiply the top by the same x to keep the value the same. Okay, so we're changing the way the fractions look, not their actual value. So let's multiply. So I have x plus 1 times 1. Anything times 1 is itself, so this just is left as x plus 1 over x times x plus 1. I am not going to multiply my denominators together or simplify just yet. Okay, I'm going to leave them factored. That way, if I can simplify later, that's a possibility. Your numerators, you're going to want to simplify everything because those get combined. But your denominator, leave it factored. You might be able to simplify later. Minus, okay, so now I have x minus 4 times x. So like I said before, I am going to go ahead and distribute this. So if I distribute the x to the x, I get x squared. And if I distribute the x to the negative 4, remember distribution means multiplication. So that's going to be minus 4x. All over the denominator we said is the common denominator. That's going to be x times x plus 1. Okay. Now we're going to subtract. All right. And what you want to remember here is that you're going to have x plus 1 minus this entire numerator. So it's this entire numerator minus the other one. What that means is you're going to end up distributing this negative sign. I will show you that. This is your adding and subtracting polynomials idea. So minus, open parenthesis, x squared minus 4x over the same denominator. So here we've got a little bit more cleanup involved. That's the only thing that makes it spicier. You're just cleaning, okay? So if I distribute this negative sign, again, you can distribute it like it's a negative 1, again, multiplication. You end up with x plus 1 minus x squared plus 4x. Negative 1 times x squared is the minus x squared. Negative 1 times negative 4x is the positive 4x. Negative times a negative is positive. Okay. All over x times x plus 1. Okay. I can collect some like terms here. I have an x and a 4x. So I'm going to combine those and I end up with, I'm going to put it in standard form as well. So I'm going to start with the negative x squared plus 5x plus 1 all over x times x plus 1. Okay. This is where I would stop yourself because sometimes you don't always see it right away, but sometimes you can simplify these fractions a little bit more and by factoring. So kind of just give yourself a little red flag and say, can I simplify? Can you factor and cancel anything out? In this case, we cannot. This quadratic cannot be factored. Okay, so since that cannot be factored, this is as simple as we can get it. So this is our new numerator. I know that was a whole lot of work just to get our numerator, but that's our new numerator. Okay, so this guy simplified is this. So now we're going to go back to what we were doing earlier, and I'm going to cheat just a little bit. I'm just going to duplicate. So that is our numerator, and then we are going to divide by our denominator of our complex fraction. Okay, so same rules apply here. We are going to do negative x squared plus 5x plus 1 over x times x plus 1. Our division symbol turns into a multiplication symbol, and then we are going to flip this fraction. This would end up being x plus 1 over x. Okay, so when we multiply these things together, again, watch what I'm going to do before I go and distribute, because a lot of people don't want to multiply 3 terms by 2 terms. It's a lot of work. So let's see if we can do anything ahead of time. So equals, I'm going to do a big long bar, and I'm going to do negative x squared plus 5x plus 1 times x plus 1. And then I'm going to multiply this guy, the x and the x. I'm going to go ahead and multiply those together. Those are relatively easy to break apart. That's x squared times x plus 1. Okay? There was a method to my madness. If we had multiplied all this together, we would have had to factor it out again. Why? Because take a look at what's here. You have x plus 1 over x plus 1. Those cancel, remember? You have common factor in the numerator and denominator. So what you're left with is just negative x squared plus 5x plus 1 over x squared. Again, you've got your terms separated by addition and subtraction here. So if we wanted to cancel out these x squareds, there would have to be an x squared here and an x squared here, and there's not. So we are all done with this one. Okay. If that is your lesson on complex fractions. So remember, that's just division of fractions. It looks scarier than it is. You just want to break it down part by part. If you've got any more questions over complex fractions, leave a comment. I'll be happy to do more examples. If there's any other specific videos, leave an example, leave me a question, and I'd be happy to find that for you. Otherwise, I will see you guys next time in class. Bye.